All right, welcome back to the second episode of our AP Chemistry notes and stuff. I don't have a better name as of yet, but I will find one. All right, so we're going to start Unit 1, Atoms, Elements, and Periodicity. All right, this is important, so listen up. Now we're going to start off with atoms and elements. An element is defined as a substance that cannot be broken down into other substances by chemical means. Any single element is comprised of only one type of atom, okay? You will find those on your periodic table. They will be there. A compound is formed when a number of these elements bond together. We just got done naming those compounds, and all this should be review. These compounds always have a fixed composition of atoms, all right? Meaning H2O is water. Anything that is not H2O is not water. It seems simple enough. When a ratio of each type of atom is fixed within a compound, so is the ratio of the masses of the atoms. And that's because hydrogen will always weigh around 1 atomic mass unit. Oxygen will always weigh around 16 atomic mass units. There's 2 hydrogens in a water, and there's 1 oxygen in a water, so it'll always be 2 atomic mass units to 16 atomic mass units for hydrogen to water, or hydrogen to oxygen, sorry. If that ratio changes, then the chemical formula changes, and then you got other stuff. You don't have water anymore. All right? All pure substances are either elements or compounds. Now, unlike a pure compound or element, a mixture has varying composition, is made up of a number of pure substances. Mixtures are either homogeneous with a uniform composition throughout. This would be like salt water. Any of the solutions that we will use for our experiments later on, those are homogeneous compounds. You will often hear me call them solutions because that's just what they're going to be. Heterogeneous mixtures are separate with distinct regions. We're really not going to get into these very often, but just for visualization's sake, a pepperoni pizza, a salad, a chocolate chip cookie, which sounds delicious right about now. It's starting to get lunchtime. All right. Now, moving on, kind of shifting gears here. Relative atomic mass in the periodic table. You may later on hear me say RAM, which will mean relative atomic mass, which is equal to the average atomic mass of an element. And you may even hear me say molar mass. And that's just because all of these things mean the same thing. I'm more accustomed to using molar mass, so you're probably going to hear me say molar mass. Here is an example of a periodic table. Your relative atomic masses or molar masses are going to be typically below on the bottom. Typically on a periodic table, you'll also see that they have decimal point numbers. These are nice, easy, rounded numbers. That's just because that's the way this periodic table is put together. I don't like the rounded numbers, so you're going to be using your periodic tables. All right. Moving on down here, and I apologize for the British spelling for formula, but that's just what they do, because they're British, and they don't have parking lots, they have car parks, which makes sense if you really think about it. The chemical formula of a compound shows the exact ratio of the atoms of the element that are present in the compound, alright? Basically saying what we just said before, water has 2 hydrogens for every 1 oxygen. Straight up that simple, alright? We're going to keep it going. Percent composition in a chemical formula. To determine the percent by mass composition of an individual element within a compound, we simply express the mass of each element as a percent of the total mass of the compound. Percents are always a part out of a whole, so if we can find the whole mass of the compound, all we have to do is divide by the individual parts, okay? Some of y'all may remember whenever we would do molar mass calculations back in regular chemistry, this is pretty much the same thing, and we can just divide. Empirical formulas will use this percent composition data to help us out. Empirical formulas of a compound is the simplest whole number ratio of the atoms in each element in that compound. Entirely different and unrelated compounds with entirely different molecular formulas may have the same empirical formula. For example, we have benzene C6H6, ethine C2H2, and 1357 cyclooctatetraidine CHC. That one, this dude right here. Sometimes these words just don't come out very easily. This guy here, that one. Anyways, they all have the same 1-to-1 ratio of carbon to hydrogen atoms in their molecular formula, so they all have an identical empirical formula of just CH. Okay, we just reduced it down. Now, here are some steps. You all wrote these down. Here are some steps to calculate your empirical formulas. Typically, you will be given some mass data. You will either be given it in the form of percentages, or you will be given it in the form of grams. If they give you grams, cool, you don't have to go any further. If they give you a percent, we're going to go straight to step A. Take the percent of each element present in the compound and assume a sample mass of 100 grams, thus converting the percentages to a mass in grams of each element. Basically meaning, if they tell you that something is 9.5% hydrogen, what you gonna do? You're just gonna say straight 9.5 grams of hydrogen. That's it. Okay, the percent sign becomes the grams. Erase all of that, move it on down. Okay, you will then find the atomic mass of each element on the periodic table. You'll go and look on your periodic tiles, which we like these little dudes. Let's just say for hydrogen here, for argument's sake, there's the atomic number. The atomic mass will be this right there, okay? This is the atomic mass. That's what you'll be using. Letter C, divide the mass in grams by the atomic mass number. This gives a quantity known as moles. Basically what you just did was turn grams into moles. A lot of y'all remember how to do that. We used a molar mass to do that. You will then find the smallest number of moles calculated in the letter C up here and divide all the results of the calculations in C by that smallest number. This will give you a ratio of the moles. Now, be careful when you're rounding here. A lot of y'all want to stick with sig figs the entire time. Be a little lenient. Give yourself some wiggle room so that when you deal with sig figs later on, at the end result, it doesn't mess up your answer. Y'all are going to learn, especially later in the course, sig figs only matter at the end. So give yourself some wiggle room. And then moving on down here to letter E, the result from D should be in a convenient whole number ratio and gives the empirical formula as a whole number ratio. That doesn't always happen, so we're going to come across some examples of that in just a minute. Alright, so for our first example here, it says, for example, to calculate the empirical formula of the compound containing 40.1% carbon, 6.60% hydrogen, and 53.3% oxygen by mass, we're going to follow this method. We made a nice little table right here. Tables are super cool because they organize all of our information. We're going to use these tables a lot throughout our AP Chemistry course. The more organized your information is, the better off and the quicker you're going to be able to see things happening, okay? So, don't get lost and confused. Keep yourself organized. It seems like extra work at first, but it really, really, really helps later on. Alright, so letter A, following our steps, we assume that we have 100 grams of the sample, so what we do is we turn the percent signs into grams. So for carbon here, it would be 40.1. Now, my friend here did not put his G's like he was supposed to, so we're going to fix him. Hydrogen would be 6.60 grams, and oxygen would be 53.3 grams. Alright, what you do then is you find all your molar masses from the periodic table. Carbon is going to be 12.011. Also, he uses a different periodic table than what I use. You're going to be using the ones that I gave you that you put in the back of your notebook. Now, according to the one that you have in the back of your notebook, carbon is just 12.01, okay? And we're going to leave that just like that. Hydrogen, he has a different periodic table, so the number that you should be putting here is 1.01 instead of 1.0079. Oxygen should be 16.00. Alright? What you're going to do is divide A by B. So basically A divided by B. And you'll get some numbers here, okay? Be lenient with your decimal points. Basically give yourself 3 places past the decimal, 2 places, 3 places, so that you have some wiggle room. 40.1 grams divided by 12.011 is equal to 3.34. Hydrogen, 6.60 grams divided by 1.0079 is equal to 6.55. And moving on over here, 53.3 grams divided by 16 is equal to 3.33. A lot of these numbers you should be thinking or starting to do some mental math to get a number that's close to you in your head, okay? The multiple choice section of our AP chemistry exam will not allow you the use of a calculator. So, save yourself some time and learn how to estimate and do some mental math, alright? Now, out of letter C, we're going to find the smallest number that we got, which is 3.33. We're going to divide everybody by that. 3.34 divided by 3.33, dudes, it's just 1, okay? I'm not worried about decimal points there. This one divided 6.55 divided by 3.33 was real daggone close to 2. You should get like 1.9 something, 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 something. That's going to be easy to round to 2. Something divided by itself is always 1, alright? So right here, in this row, we have just figured out the ratio of the atoms in our empirical formula that we were given, okay? So, there's a couple different ways we can write it. This example, C1H2O1, uses the 1s, but we're cool kids, and if it's not there, it's understood to be a 1, so it's CH2O, boom. Alright, this is what I expect y'all to be writing right there. Alright, now we're moving on down. We're going to do a couple of these examples, and they will not be nice, easy examples. Oops, gave y'all the answer right there. Alright, give me a second because I need to take a drink of this Coke. Alright, doing good. Now here we're going to follow the exact same thing. I've set up a table. We're going to erase and plug and chug as we go. Alright, so we're going to start here for letter A. Alright, I'm going to use green because I can. And go away. Alright, so here for FE, all we got to do is get rid of our percents and turn them into grams. So that's going to be 77.78 grams. This dude here for oxygen is going to be, oops, don't you dare write a 0 right there. 22.22 grams for oxygen. So I'll just go ahead and label O, FE right here so we don't get confused. Alright. And we'll just keep it going. Now, using your periodic table in the back of your notebook, we need to put the molar masses of iron and oxygen here. 55.85. This guy here is going to be 16.00. This row right here, we can keep the same for the rest of A, B, and C because that's it, because it's going to be the same. It's just iron and oxygen all the way through. Now, in the event that they start changing up chemicals on you, fix your stuff. Alright, row C here, if you go back up, that's going to be the percent by mass divided by the atomic mass. So you come over here to your handy dandy calculator, which you cannot see, but I can. 77.78 divided by 55.85. Boom, I end up with like 1.39, and I know it's not going to change much past that. Moving on to the next one, 22.22 divided by 16. And again, it's about 1.39. I know the smallest one is pretty much the same as the other. Divided by itself is 1. And I find that the ratio of atoms is going to be a 1-to-1 ratio. Basically, it's 1 iron for every 1 oxygen. This guy right here is ugly in Spanish, F-E-O. Alright, we're going to keep the same format going for the next two, for B and C here. Alright, I will be changing up colors because, well, I can. And get rid of you, erase, there we go. I'm going to use red now. We're going to change our numbers so we can do B. This will be 70. I'm not even going to add the 0.00 because I'm saving myself some time. I'm not even going to add the 0.00 there because I'm saving myself some time. Our AP exam is all about time management, and if we can buy ourselves minutes for later on for the tougher questions, by all means, we have just saved ourselves a lot of headache. Alright, so for letter C here, it's going to be A divided by B, so 70 divided by 55.85, and don't hit that button. I end up with 1.25 right there. For this one, I know my answer is going to be close to 2, but we'll see. Make sure you actually put 30 in the calculator, not 3 dots in the calculator. And I end up with 1.875. I'm going to include those numbers there because it's going to be somewhat helpful. Alright, now I got to divide both of these guys by the smallest one. So I'm going to divide by the 1.25 on both sides. That's going to be 1. Now here, the 1.875 divided by 1.25 is going to give me exactly 1.5. Do not round up or down here. This is a nice in the middle number. What that means is I need to make it a whole number. To do that, I will need to multiply 1.5 by 2. But since I'm multiplying him by 2, I need to multiply the other side by 2 as well. Okay? And that's going to give me a nice whole number. I need those whole numbers, because I cannot have parts of atoms. Once you start splitting atoms, you end up with nuclear explosions, and we ain't about that life. Alright? Alright. So I end up with Fe2, because there's going to be 2, O3. And I'll write that right here. O3. Alright. And I will use the blue color for the next set. For letter C here. Let me erase my stuff here. Whoop, I got rid of my line. It helps when you make sound effects, y'all. Oops, I didn't need to go that far. There we go. Alright. Here for letter C, moving on down. I'm going to fill in my boxes. 72.4. I'm not even going to write the 0. Save yourself some time. You don't need it. 27.6. Alright. Now, do my division. 72.4 divided by 55.85. Boom. I get 1.296. In my calculator, I'm not going to carry my numbers past that. For oxygen over here, 27.6 divided by 16. I end up with 1.725. Again, we will divide by the smallest on both sides. That's going to be 1. Now here, it's going to be 1.725 divided by 1.296. And I end up with this number. Now at this point in time, you should be thinking, holy guacamole, I'm done. I'm dropping the class. No, please don't do that. I kind of need y'all to stay in here because it's a fun class and I really enjoy teaching it. Alright. If you'll recognize, if you ever see this number, that is equal to a third. Okay? Get good at changing decimals over to fractions. It will be very, very helpful for you. Fractions work really, really well when it comes to mental math. Some of y'all may disagree with me. I will argue you every day. Alright, hang on. Let me drink this Coke and then we'll keep on going. Okay. To get to a whole number here, I will need to multiply by 3. So I'm going to multiply him by 3. 1.33 times 3 is going to give me 4. Multiply him by 3, and that gives me 3. So what I find is, for my empirical formula, it's going to be Fe3O4, just like that. Okay? And that is my empirical formula right there. Now to move on down here to example number 2. Scroll, dude. There we go. No, you tried. You tried so hard. Alright, we're going to try that. Haha. There we go. It says, which of the following are possible empirical formulas? Explain your answer. Now, if we remember back, this is just a vocab question. An empirical formula is only the simplest whole number ratio of atoms. So looking at here, I'm going to use red. CH, that's 1-to-1 ratio. He is empirical. 1-to-2 ratio, I cannot simplify that down any further. He is an empirical formula. C4H4, can I reduce him? Oh, definitely, that will reduce back down to CH over there. So no, he is not an empirical formula. CH3O, that's a 1-to-3-to-1 ratio. He is empirical, okay? If you see anything with a 1 by it, it's probably going to be an empirical formula. Now this guy over here is going to test your math sense, your number sense. I can divide, if I divided everybody by 3, 3 divided by 3 is 1, 6 divided by 3 is 2, 2 divided by 3 is not a whole number. So, because it's not going to give me a whole number, this dude right here is going to be an empirical formula. We cannot simplify him down any further. I am not going to write out the explain your answer part because I just told you. However, I would expect you, and AP would expect you, to write out explain your answer. Okay? Alright. That concludes our episode 2 for today. Alright, now I gotta get it out of this and save this and send it to y'all. Here we go. Boom.